All right. Well, happy Tuesday. So we are here. I just posted the syllabus. Sorry, it got behind. New Year's was great, but then we got sick. I'm just getting over a sinus infection, so I don't feel so good. The antibiotics are fantastic, though, so I've been on them for days now. I should be fine. And no one's sitting up next to me anyway, so that's pretty good. That's the wrong one. No. So out in Canvas now, there should be one thing here. It's just the syllabus. So we're going to take a little bit of time, go over that today, go over some of the tools, and we will do lab later this afternoon. If you've had me before, you'll be really bored because we'll practice GitHub. If you've not had me before, it'll be a lot of fun because we're using GitHub. So it's a lot of fun. Don't worry, I'll show you how to do it. But this is section 6 of CIS 200. We meet Tuesdays and Thursdays here in the PEC 11:30, 9:30 to 10:45, and then Tuesdays for lab over in the ELB 2026. The ELB is the fancy new building there on the second floor. This is me. I'm a lecturer 2, Leo lecturer. I'm not a professor. I might give you a hard time if you call me professor because it amuses me that the administration won't allow me to use that title until I've worked here for 12 years and then ask them nicely if I can please use that title. And I just like to point that out here. So that's okay. This is my email address. If you use Canvas to message me, it goes to the other non-priority inbox. If you email me directly, instead of doing it through Canvas, it'll come to my main inbox. I don't turn on notifications from Canvas to my main inbox because every single time someone submits something, I get an email from Canvas, and it's irritating. That's okay. It's nice to have, but I don't want them to be popping up on my phone all the time. So if you email me direct, I get it right away. It shows up on my phone. If you like to call or text, this is my cell phone number. I think I've got a phone number here on campus with a voicemail, and I'm pretty sure the voicemail says, please don't leave me voicemails, because I never check it. In how many years now? 7, 8 years here of teaching? 7 years of teaching here. I've never checked it, so please don't do that. Use my cell phone, perfectly fine. And then I'll post a link for you later if you like Discord. I have a Discord server that I like because Discord's great. I think a lot of folks are already on Discord. It's a fantastic tool. That also goes right to my phone. So lots of ways to get a hold of me, pretty easy. If you want to chat, I'm in CIS 239. That's the CIS building is the weird one that has no classrooms in it. There's a lab, but no classrooms. It's the brick building over that way. Soon to be renovated, maybe? They will be proposing a renovation plan to the Regents to approve, asking for funding to spend a bunch of money on a building to redo it at some point in the next 5 years, maybe. So that's the plan. But Tuesdays after class, before my next one, and then Thursdays between my classes as well. I'll be hanging out there. If you don't see me around, I might be in a meeting with somebody. Just call or text me, and I'll let you know where I am. But I'm going to be on campus, but maybe I went to get coffee or lunch or something. So just shoot me a message if you don't see me there. We can definitely call. If those times don't work for you because you have other classes, let me know. We have lots of tools, and we can meet virtually. Sometimes I'm around, other times we can meet. Got lots of options. The course description, this is right from the catalog. This is boring. Our program learning goals, you can take a look at the different goals here. Those are fine. Specific course objectives, these ones are fun. They might not mean a whole lot yet because we're just starting, but eventually through the semester we're going to hit all of these different things. So looking at algorithms, determining their efficiency, this is a big theme that we start getting into. You really tackle this deeply in CIS 350, your algorithms analysis and design. I think that's the title. It's a little early in the morning still. I haven't had enough coffee yet. But we start that. So as we start looking at data structures, we look at how they perform, why they perform the way that they do, and we build them by hand, which is terribly dull, so that we have a better appreciation for why they perform the way that they do. Right? That's really the reason why we study them. Not that we're going to rewrite them ourselves, because people with PhDs have studied these things and made them more efficiently than anybody else can, which is great. We love it. We're going to use the standard library all the time, because they're fast in the standard library, but we're going to learn to write them ourselves so we can understand why they work the way that they do. We're going to create test cases and test plans for unit and integration testing of medium-sized programs. This is one of my favorite topics because testing is always worth your time, because if it's worth your time to write the code, it's worth your time to make sure the code does what the code is supposed to do. Otherwise, you have garbage. Right? If it doesn't do what it's supposed to do, you have garbage, and no one wants garbage, especially for important software. Like apps on your phone, sure, it's probably not the end of the world if bad stuff happens, but something like my insulin pump here, if the software on this doesn't work right, I die, literally. So I appreciate people writing software that works the way it's supposed to work, because this is my pancreas now. We'll create stub procedures and drivers as needed to perform top-down or bottom-up integration testing of programming, just different methods, different approaches for testing, right? Bottom-up or top-down. We'll get into that. We'll look at trade-off considerations for data design implementation. Again, the idea of looking at algorithms and their efficiency, how we design and manage our data. We'll look at that for what is good, right? What's the ultimate goal here? What are we trying to accomplish? Some things you want to be fast for writing. Some things you want to be fast for reading. Right? It just depends what we're trying to do. We'll look at design software so it's easily modifiable. Also love this topic here, looking at how we make our software easy to continue its life. Turns out software engineers are expensive. That's probably why you got into the field, because you make a lot of money as a software engineer, I'm guessing. That's okay to admit that. Right? That's perfectly fine. I hope all my kids go into software because it makes you a ton of money, which is great. But making it modifiable is important because software is expensive, companies want to use that software for a long time. Right? The longer they can use a piece of software they paid someone to write, the more money they're getting out of their return on investment. That's what business is like. And you can eventually you'll take some classes and learn all those fun buzzwords. But they spend a bunch of money to get someone to write software. They want to use that software and make money using that software for as long as possible to milk out every single dollar they can. So if it's easily modifiable, we can have the software be maintained and keep it up to date. And things change, processes change. It's cheaper to modify software than it is to write brand new software. Right? So if we make it easily modifiable, then that's easy for us to do in the future. We'll implement algorithms using linked lists, stacks, and queues. These are some of our initial data structures we'll get into. They're lots of fun. We'll do some projects on them. We'll incorporate various sorting algorithms into program design. We'll look at some sorts, various ways we can sort near the end of the semester, figure out, hey, the standard library sort's probably the best one anyway, but that's okay. There are some trade-offs there. We'll use existing class libraries, create a program using object-oriented analysis and object-oriented design techniques. Love object-oriented programming. It's a natural way for people to talk about things and design things because we like objects, because we understand objects like chairs. Chair's an object, right? There's different kinds of chairs. Your chairs have 4 legs, mine have 5, but they're all still chairs, right? And this sort of thing we'll get into. This should have been one of the last topics you had in 150, I believe, right? Talking about objects, object-oriented design, classes. Only a few of you are shaking your head. I know it's early. And we'll use object-oriented design to create libraries of related classes that can be used to solve real-world problems. This is a bit of a stretch here. This is only our second programming class. We're not solving lots of interesting problems. We could possibly solve some real-world, very simple problems. But again, we're getting there, right? The idea is, how do we use this, make our libraries of related classes here? How do we design things to solve problems, right? Works out pretty well. We'll utilize data abstraction, data hiding, functions inheritance, and pointers in C++. So hopefully abstraction, data hiding, functions, and inheritance were things you've heard before. We're going to go deeper on these, right? Spend a little bit of time. This will be our first project we'll be working on with this sort of stuff here, right? Writing classes, using good data abstraction, data hiding, private values with public functions, right? So we are encapsulating all of our details. We give someone a public abstract interface to work with. Okay, it'll be lots of fun, don't worry. And this last one is also part of the topic of the first week. Here is the Unix file system with Unix shell commands. Our second lab, where we start doing some Unix things there, is the only time we touch Unix, which is part of our accreditation process. When we're accredited by ABET, the something of technology, I forget who, one of the things they look at is, have we taught people how to use more than one operating system? So we start now. In CIS 200, we'll have a chance to play with things in Unix, which is awful. It's okay. Really interesting. It's not Windows, though. You don't get to click on things, and that makes people sad. But that's okay. We'll be all right. So we'll do that for the lab. It's a lot of fun. For textbooks, the main textbook is actually the same Zybooks that you probably used for 150. So if you went and printed off the PDF version of it, you still have all the content. It's just not clickable. It's okay. If you didn't, for some reason, I guess everyone uses different things sometimes, even though we're all supposed to use the same thing. I get confused by that. You can get this semester's version. I'm not giving points for doing the Zybooks, like you probably got points for doing it in 150, because you had already bought the book. And I think if you contact the Zybooks folks, you can get a discount on getting it again if you didn't get it, or if you did get it in the fall for 150, because it's basically the same book. They can do something. I don't know exactly how it all works. I got to ask the Zybook rep again how that works. But there's a new Zybooks. Again, it's the same thing. We're just covering the later chapters. Right? You probably just did some of the beginning chapters last time. We're going to do the later chapters and dive a little deeper in. So apologies on that, but there's no points for doing it. So if you've got the PDF, great. You can do that. It just won't be clicky to go through. The clicky stuff was kind of fun. And we won't be using Zylabs where you do all the really tedious lab stuff where it cares about every single particular space, which is important. Some attention to detail is useful. That's a good skill, but was very obnoxious. But generally, my school of thought is the only way you get better at doing something is by doing it, which I think is a pretty universal principle, right? No one gets good at playing an instrument by looking at their instrument or reading books about instruments. They get good at playing an instrument by playing the instrument. Same thing with coding, right? So if you read about code, watch people code, you're not going to get better at coding. Right? You have to do the coding yourself. So some practice is good. That's why we have our weekly labs. We've got lots of projects, stuff we'll be going through. But this will give you some practice. In addition to these, we have some recommended books for those of you who like textbooks, which are actually halfway decent here. They're just crazy expensive, and I don't like Pearson because of that. You could go check out this book. I think there's a copy in the library. I don't know if they let you check it out, but you can go just read it while you're in the library. I think it's like a reference desk copy or something like that. Data Abstraction, The Problem Solving with C++ by Carano and Henry. It's actually a really good book. Lots of good detail in there if you like textbook style things. If you're looking for more examples, it'll be very focused on the level and things that we're doing here. If you just go out online and look on YouTube, there's tons of stuff out on YouTube, but it's not always the right, topic for topic level that we want is part of the problem. So that's a great reference. Excuse me. And then there's 2 books on Unix if you are entirely bored. You're welcome to go check these out. I don't mean to trash on Unix. It's super great, super powerful. We can do lots of great things with it. But teaching people to use Unix is like pulling teeth. It's no fun at all. Once you get comfortable with it, it's fantastic. So at some point, it's useful to get used to these command line sort of interfaces, these sorts of things. There's a good time and place for it, but I'm just not fond of doing it your second semester. But that's what we do. So I don't make the rules. The tools we're going to use. I'll be using Visual Studio Community. If you're on a Mac, you can use Xcode. I've got some instructions, but you already had a full semester of it, so hopefully you know how Xcode works and how to install it, that sort of thing. In Windows Land, Visual Studio is so much nicer. It's a way better tool anyway than Xcode. It's great. So yeah, we're also going to use github.com. This is a hosting provider of the Git source control tool. So Git is a source control tool made for managing source code, which is the code that we write, started by our friend Linus Torvald, the founder of Linux. It's an amazing tool, tons of powerful features. We're only kind of scratching the surface here, but GitHub gives away their services for free for open source or educational use. And we fit the educational use here. So I will have links that will create private repositories. The only thing that's public is your username. So use whatever you want. It doesn't matter. You're going to turn in links into Canvas because code is not meant for Canvas. Canvas is a terrible place to put code files, and I hate it. I will not put code in Canvas. You will not put code in Canvas for me. If other profs ask you, other lecturers ask you to put code in Canvas, you just smile and nod. And sure, that's what they want you to do. I don't want code there because it's awful. Then I have to download it and put it in projects, and the whole thing is awful. So I'll show you how to use GitHub. It is amazing, I promise. It takes some time to get used to. So if you didn't have me last semester, you've got a bit of a learning curve, and that's okay. Right? Everyone starts somewhere. It's not the end of the world. It's pretty quick. But it's like 7 steps. And we just repeat those 7 steps every time we do something. You'll get there. I like using the GitHub desktop client because this is the same client for communicating with GitHub, no matter what language I teach in. Visual Studio has plugins. Any IDE has plugins that will work with Git. But then I have to show people how those particular plugins work and how you log in and all those things. The GitHub desktop client is the same one every time. So it makes my life easier. And it's fine. It does all the things we need it to do. All right, I'll show you how to install all those. Don't worry. For grades, this is what everyone seems to care about: how you get your score at the end of the class, right? And this letter scale should be standard. If I did this right, this should have come out of the template, so shouldn't be any questions here. But right, if you're looking for a particular letter, right, this is how you get there percentage-wise. So I use a weighted system. So there are points in each category, but the points only matter for that category. So if labs are worth 10 points and projects are worth 10 points, they're not actually worth the same 10 points, right? Because your labs are worth 15% of your overall score. So whatever you get, if you get 95% on your labs, you get 95% of 15% for your going towards your final 100% in the class. Does that make sense, these categories? Okay, you guys are good at math. You're at least in calculus by now, right? Calc 2, I think, was the minimum as a co-rec for this one. Great. You're going to love Calc 2. Lots of fun. I almost kept a straight face. It's interesting. I was told, I don't know much about it. One of the reasons that software engineering students or computer science students take calculus is the sequences and series chapter that you do in Calc 2. That was super interesting when I took it. Not very useful, I'll be honest, as a software engineer, but that's okay. Depending on what field you get into, you may or may not ever touch calculus again, right? My brother's friend went to school, did his entire master's thesis on how you can efficiently draw curves in programs, and works for AutoCAD. Kind of important in some of the math there. Does a lot of math in AutoCAD, right? 3D designing and modeling of components and things uses a lot of math, go figure, right? As a software engineer, I worked for almost 20 years in the industry, never once had to do advanced math. Well, that's okay, right? I did healthcare software. There's not a whole lot of math there. It's just maintaining records. Anyway, so you'll love calc. Sorry, my sugar's a little high right now. That's not good. Come on, pancreas. Let's see. This beeps at me anytime it's out of range. All right. Individual projects, we'll have 4 individual projects. Those worth 25% of your score. We'll have 2 weeks to work on each of those or so. Lots of time to work on them. The midterm is only 10%. That's the only exam we have in the class. I don't love exams. I think they're dumb, but I get funny looks if I don't include an exam in the syllabus. Just, okay. So 10%, not worth a whole lot. It's low pressure, right? It's open book, open notes, because I've never once been asked by an employer to please do something from memory, because that'd be stupid. And you just can't memorize it all, right? No one has everything in their head. It's not worth it. You want to know where to go find the information. That's all you need to know, right? Eventually, you'll keep some of it in your head the more often you use it. There's a lot of shortcuts, a lot of tools, a lot of things that I know because I've done them a lot. But that's okay. If you don't, just go look it up. No big deal. We'll have quizzes. Every chapter will have a quiz. I write them myself, so occasionally there's typos. Let me know if they don't make sense or if something seems a little weird. They're pretty easy. The idea here is I give them so that you do the reading, honestly. Right? You don't even have to read all of it. You just need to know where to go find the answer. Hey, this question is about stacks and queues. It's particularly about the performance of stacks and queues. Okay, let me go find that piece. That's all. So to keep up with the reading there. And then the final project, or the group project, this one is a group because one of our objectives here is we work in groups, function as a team here, which is fantastic. And by group, I probably mean like 2 people. More than 2 is probably more than we need. Maybe a trio. Maybe, if we don't have the right number of people here. But there's not enough work for 4 people to do it, okay? But that is 40% of your score. The idea here is you can't pass the class without this. That's why it's worth 40%. That's what it is. So instead of a final exam, we have a group project, a final project that you folks will present to the class. That'll be a lot of fun the last day. Instead of doing a final exam, you'll get up and run your software. We'll talk through it, show us that it does what it's supposed to do. You might have a couple questions about the code. It takes 5 to 10 minutes tops. It feels awful, but it's good practice. Showing your code to your peers is something you'll be doing in the industry when you go out and work. Or if you stay in academia, you still show all your stuff to peers because you have to publish papers, those sorts of things. So getting a chance to talk in front of people is rough until you've done it a lot, okay? And even then it can still be rough, but that's okay. We'll get through it. It's very supportive. Everyone claps for you at the end. It's fun, okay? So the tentative plan here, tentative, it changes if we need it to, but here's the current plan, is we'll do the course intro, GitHub, and Unix the first week. Lots of fun. We will have our lab today. We'll work on GitHub. Our lab is a little bit funny because it's on Tuesday between the weekly lectures. So it should work out okay. We'll try and get through most of the stuff on Tuesday, have the lab on it Tuesday afternoon, evening time, 4 p.m. to 5:45 p.m. And when you're done, you're done. You can leave. If you don't want to come to lab time, honestly, you don't have to. But if you have questions on the lab and have trouble with the lab, that's my time that I have to work with you. Right? That's the time that we have set aside to work on the lab assignment. So if you don't come to lab and then you're like, hey, Eric, I'm having trouble with it at other times, I'll help you. But if you like keep doing that over and over and over, I'll be like, just come to lab. Right? Lab is the right time for this, okay? Not the other times. But if you can't make it, you can't make it. That's okay. I don't take attendance at them. You just have to turn it in. And they're always due the next week. So you've got a week to work on them. Right? If you started your day at 9:30 in the morning and you don't want to be here till 5:45 p.m. because you're just fried by the end of the day, I get it. That's okay. Right? You probably aren't used to 8, 9, 10-hour work days yet. Eventually you'll get there and you'll love it. It's amazing working a 40-hour week job, I promise. Again, sorry, it's hard to keep a straight face. But you'll get into the flow of things. So we'll get there. But you get the stuff done, as long as you're thin by the due date, we're happy. I'm apparently royal. I call myself we all the time. I apologize. It's a bad habit. I'll work on it. I'm not muted, right? Okay, good. So just a reminder, if you came in late, I do record things. I use OBS to record my desktop, myself talking, and I put it out on YouTube because that's easy. So it's public. So if you don't use your name, I won't use your name, and then it doesn't get public out on YouTube, and everyone's pretty happy. If you've got concerns, let me know. I could make private listings, but it's a little more obnoxious and troublesome. It's easier to make them public, and that's just what I would prefer. But it's okay. I'll be flexible if we need to. All right, and then next week, we'll get back into objects and classes and do a deep dive on objects and classes, have a lot of fun with it, get into exceptions and pointers, and start our first project. Okay, and then we'll talk about arrays and vectors again. Hopefully you did these a little bit. We'll go a little further, do two-dimensional arrays and vectors, have lots of fun with them, and then get into inheritance and start project 1. So we'll do a project on classes with exceptions and pointers, and then we'll do a project on using inheritance with arrays and vectors. There's lots of fun. Then we'll start talking about the containers, the abstract data types. This is the stuff from the standard library in chapter 11. And then we'll get into recursion for project 2. Recursion is great. It's a very interesting technique for solving problems. Hopefully you had a chance to talk about it a little bit in 150. We'll do a deeper dive in this class, right? And then it's labeled as spring recess. I actually had to look this up in the academic calendar. It says spring recess, but the last week of February, first week of March is not spring. So I don't know why it's called spring recess, but that's what it was called online, so I went with it. We'll just pretend it's spring, I guess. So we have a week off, no classes that week. We started project 2. You've got 2 weeks to work on it of class time though, so feel free to take the whole week off. Don't do anything for class, please. Right? Need a little bit of time to recharge. Then we'll come back and work on templates, and then the linked lists. Then we'll start project 3 that uses linked lists. Lots of fun. We'll take some time for midterm review in the midterm. Again, not meant to be high pressure. It's not meant to be high stakes. It's open book, open notes, open internet. Right? Just know where to find the information. Okay, it won't be too bad. I'll give you, last time I taught this class's midterm so you can see what the questions look like, because I write questions differently than other people do. So we'll show you that, go over the answers. And then we come back, review project 3, and then we start talking about stacks and queues. We get into the group project. So we've got a month for that group project because it's worth so much of your score. I want you to have lots of time to work on it. We'll talk about searching and sorting. We'll talk about streams and ethics. We come back to streams again. We look at slightly more advanced file streams. They're a lot of fun. You can do some really cool stuff with them. Much of what is done in enterprise applications is always backed by a database, because that's where data lives for shared data. There are some still specialty use cases and things. If you just have a local program, you have local files that you work with. That's great. Doing local files and streams is still good and useful. Not everything goes out into a database, but more often than not, data is going to be in the database. We just keep some certain files around in streams, local files there, which is fun. And then the last week of class I've set aside. I have no plans on talking. The idea is here that you've got some in-class time where I can float around and help your group, your partner, right? Just generally twos. Plan for pairs. It'll be good to work on that group project where I can answer questions. Lab will be the same way that week. I can answer questions for your groups. You've got some in-class time to work on it. I know you folks are busy college students and have lives. It's hard to have a life and do school and do all your other things. I get it. So we've got a little bit of time set aside. And then our final exam slot, if I did this right, I looked this up here. We meet Tuesdays, 9:30 a.m. We should be slot E, which puts us at Tuesday, April 23rd, 8 to 11 a.m. 8 is super, super early. I'm so sorry. That's awful. But again, they're just presentations. Hopefully, the goal is you can have it done before final exam week, because we've got enough time, right? We're starting on the 26th or so to start this thing. So that gives you almost an entire month to work on it. If you can get it done and out of the way, that's great before the rest of your finals. Right? That's the goal, and that's what we tried to do last semester in my class. I think it worked out well for most people. And again, things will go as they go. When we get to the group project, I'll have some specific requirements for that you have to meet, and that you have to be doing work at certain stages and certain amounts of time. Like you can't just turn it all in the last day. We'll talk about that when we get there. Okay. The goal is to help you work ahead on it and to make sure you're not just cheating. I'll be honest. Right? That's one of the reasons you have to contribute work throughout, and we'll talk about that. Course-specific policies. This one is a bit of a pet peeve of mine, academic integrity. You should not cheat and get a degree. And all of you hopefully will understand that that's also good for you, because if people cheat their way through school and they get hired and they don't know what they're doing, they'll get fired, and then the employer will say, hey, U of M Dearborn does a crappy job teaching people, we're not going to hire other U of M Dearborn graduates. So it's in your best interest not to let cheaters pass either. Don't let people cheat off you, because they will suck, and then no one will want to hire people with our degree, right? Because they don't know what they're doing. You have to do the work, right? I get college, it's weird, right? A lot of people want a piece of paper. That's great. But what really matters is, can you do the work? Hopefully we're training you and educating you well enough to learn how to be productive and apply the things that you've learned to be good at what you do. Software engineering, computer science, whatever you end up in the field doing. You should be good at it because you've learned a lot of different tools and techniques and cool things along the way, right? If you just cheated your way through to get the piece of paper, you won't be able to do the job because you didn't learn anything along the way, and it sucks. So if you do cheat, right, if you violate our academic integrity policy, which most of the time is plagiarism, right? Most of the time it's, hey, I found something online, I turned it in without citing my source. That's plagiarism. Just like an English paper. You can't turn in someone else's paper and put your name on it, right? Plagiarism is a big thing. It happens in code. Now, the joke is software engineers around the world all plagiarize each other. We've got websites like Stack Overflow, and now there's chatbots and interesting things. We do that in the real world. But in academia, you still have to cite your source. In the real world, you should still cite your source, right? At least so you know where to go back to find more information. It's useful to have in academia. Sorry, give me just a moment. All right, that's the last little bit of my cold going through, that sinus infection. In academia, you must cite sources, otherwise bad things happen. You might have heard of some prominent people out in academia who recently were able to resign after it was found they had cheated and plagiarized on their PhD paper. Was it the president of, was it Harvard? Ms. Claudine Gay, I think it was, recently resigned because it was found that she had plagiarized on her PhD thesis. It's a little bit embarrassing as the president of a university, just a little bit. A little bit embarrassing, that sort of thing. But that works for our projects as well, right? I know there's tools out there. I know there's websites out there, right? I know there's chatbots. Chatbots are great. You will use them in industry because they make you more efficient, right? The problem is chatbots don't do everything. They don't. They can solve small problems and small projects. We've trained them on websites like Stack Overflow, which is an interesting issue because once people stop using Stack Overflow, there's no more data to train them on. And then it like eats itself and it won't be able to evolve. And it'll be interesting as we get there. The chat AI space is super interesting and hot right now. Lots of fun stuff going on. But U of M hosts a chat GPT tool. And you get the version 4, which is the latest one that I understand, instead of the OpenAI one that you have to pay for version 4, so don't pay for it. But U of M has one. You're welcome to use it, but you have to cite your source. Now, OpenAI gives you links that show me the thread, which is really nice, but you have to pay for that or use the not as efficient, not as good version of it here. So if you use the U of M one, great. What you're going to do to cite your source is tell me what your prompt was. What did you ask the chatbot for in your citation? You have to tell me what you asked for. Right? And you're going to cite your small pieces here. Now, same thing with an English paper, though. You can't turn in one giant quotation. You don't say, hey, I asked ChatGPT to write my paper, here you go. That will not fly, right? You can't do that. Not one giant citation doesn't work. You have to have original effort added to these sorts of things. I'm not an English major. I don't know what the going rate is for English papers, but I would ask for about at least 50% of your original work and up to 50% cited sources. Right? You can take some sources. I know there's things online. People use their sources online. That's good. You're more efficient that way. Great. But you have to add in your own work to it. So at least 50% of it needs to be your own original work, right? And then maybe you can cite some other stuff. That's great. If you want to look up an example and then use it, that's more of a paraphrase, right? Hey, I found a way that they did it. I'm going to take that and model after it, but it's not going to be a quotation. I'm not going to copy paste it. I'm going to kind of tweak things. That's a paraphrase. You still cite your source, right? It's just like you do in English papers. If you don't use word for word, you still say, there's where I got the idea from. Okay? We can do that. It's not hard, I promise. I'll show you how to do it. But if you don't cite your source, the penalty is failure in the class. There's no 0 on the assignment. There's no try again. There's no nothing. You will not pass this class if you cheat and I catch you. That being said, I might not catch you. I'll be honest. I don't catch everyone. But I've been teaching since 2012, and there's not yet been a semester where I haven't failed someone for cheating. It's actually really sad. It irritates me. It gets me all upset, and then I'm like upset about it, and I complain to my wife, and then my wife gets upset because she's like, Eric, why are you yelling at me? I'm like, I'm not yelling at you. I'm just frustrated people cheat. It's not hard not to cheat. All you have to do is cite your source. And she's like, just let it go. So I'm getting less personally irritated by it. I know it's not a personal offense against me. if you're lazy enough to cheat and not cite your source, you're way too lazy, right? At least if you can be lazy enough to cheat, just cite your source, right? This is what we do. We cite our sources because this is academia. It's not my idea, it's someone else's, right? You can do that, I promise. And then we can add some original effort because you're learning something in the class, hopefully. If you're learning nothing, don't come, right? If you're not learning anything, don't come. You're wasting everyone's time. You don't have to be here. I don't take attendance. I don't make you sit in the seat, okay? Don't be here. It's that easy. Sorry. Like I said, this one's a little bit of a hot topic for me. I apologize. Yeah, but cheaters shouldn't pass. It's for the good of all of us, okay? So you will fail. You get reported to the dean's office or the is it the college committee now? There's a whole process now. I have to, and this is why I hate it too. There's like ridiculous amounts of paperwork I have to do to show that someone cheated. And then I have to do a bunch of paperwork, and I hate paperwork. Paperwork is the worst thing in the world because it takes away the time that I should be doing interesting things, useful things, because I have to fill out paperwork to tell people that people cheated. One last fun story about this, and then I'll move on to another topic. I apologize. Back when I had final exams, so before, one of the good things that happened of COVID is we realized, hey, maybe final exams are stupid and we should give final projects and like talk to people and have them present their ideas. And we can actually see, do they know what they're talking about? Because if you cheat on your final project and you go up and present it and I ask you questions and you say, it's pretty obvious, okay? Because you have no idea what your code does because you didn't write it. That's really obvious, really quick, if you don't know what you're talking about. But back when we did final exams, I had 8 people copy paste an answer and turn it in. One of those people cited their source. They said, hey, I found an answer. Here's where I model after. It was mostly word for word. I had to change these 2 things, whatever it was here. 7 of the 8 did not. I'm like, oh, that looks the same for all of you. That's interesting. And I go out and I Google and I find their source. So 7 people failed the final exam. CIS 200 is a prereq for other classes, in case you weren't aware of that. So registering for the next class in the sequence, I think it's 350, is typically what you take next. There's a recommended sequence you can look online. I'll show you later if you're curious. They can't take that class if they don't pass this one, but it was the final exam. They'd already registered for the next one. So all 7 of them freak out. They go talk to the dean. The dean's like, okay, well, you failed for cheating. Tell you what, we'll let you take it again at the same time. But because it was already at the final exam time, classes were going to start in like 2 more weeks, they ended up asking me to teach these 7 people again because no one else was available to teach. So they had to take my class again. So I got paid to teach them again, give them assignments. It was essentially an independent study. I gave them new projects, new assignments to work on, and they had to pay to take the class again. Classes here aren't cheap, in case you noticed, right? Credits aren't cheap. So having to take more credits because they cheated sucked. But I made money off of it, so that was good, right? I'm glad you laughed at that. That's good. I appreciate that. It's not that early in the morning to think these things are funny. That's good. All right. Anyway, don't cheat, please. It pisses me off, and it's bad for everyone, okay? If you have questions, ask me. I know I sound a bit of like a jerk right now. I'm kind of a nice person. Ask anybody who had my last class, right? I was okay. You ended up taking me again, so I see a couple of familiar faces. I must have done something okay. Or you just registered late again, because last time you guys were the last class, and everyone who registered late got in. Anyway, late projects and homework. I don't take things late without some sort of pre-written approval. Hey, something was going on. The reason is, you might have noticed here, we have reviews of all the projects. I generally think it's sort of worthwhile for me to show you how I would solve the project, right? Generally, that you see something out of it, because I might approach it a different way. I've got different ways of thinking about things, and I talk through the process. So I solve all of these projects I can do in 1 class time. They're not that big, but I also have like 20 years experience. So don't feel bad if it takes you more time. It's supposed to take you more time as you work your way through the projects, okay? That's all right. If you can get them done in an hour, it's not hard enough. I'll be honest, right? I can get them done in an hour because I know what the project is and I have solved it, that sort of thing. So, but that's generally how those work. So we do review time. So I can't take it late because I've already gone over an answer, right? So that's why we have 2 weeks to work on them. So start them early, please. Ask your questions, and we should be in good shape. Now, we're fortunate here. Classes are Tuesday, Thursday, because when I had a Monday class and people had questions, they were asking me Sunday, and I'm a little bit busy Sunday, so it was hard to answer questions on Sundays. I tried every now and then. I've got some really weird hours. I've got 7 kids at home, so I like to work when they're asleep. So usually I'm up till like 3, 4 in the morning working after the kids are in bed, because that's my quiet time in the house. And it's great. I've never been a morning person, so getting here at 9:30 in the morning will suck, but we'll figure it out, and we'll have lots of coffee. I didn't bring my thermos. Usually I have a thermos of coffee. I didn't get up early enough to make a pot, though, but that's okay. So lots of coffee, but I don't take stuff late because we go over the answers. So please plan ahead. And the other thing is, you'll actually be grading yourselves on the projects. I'll give you a rubric that says you get points for doing this, points for doing this, points for doing this, points for doing this. You grade yourself. You tell me you got this part done, you got this part done, you got this part done. We're going to be a little bit more detailed than we were last semester, if you had me last semester. So you'll be putting in some screenshots showing me where it did this piece, showing me where it did this piece, showing me where it did this piece, as you're evaluating yourself. Because you know what it has to do, so you're going to show me that it does what it's supposed to do. Okay? Promise, I'll show you how to do it. It'll take a couple times till it feels comfortable, and then we'll be good at it. Again, we're going to use the GitHub website because they're fantastic, and I love them. The food pantry, we do have a student food pantry. There's this idea, what is it? Hierarchy of needs. Hierarchy of needs. There's Maslow, I think? Yeah, Maslow. He's a cool guy here in psychology. Turns out to do anything interesting, and interesting is maybe the wrong word here, I apologize, I'm not much of a psych person here. Anything creative, you have to have these other things, which include your physiological needs like food, water, shelter, safety, these sorts of things. If you don't have those things in place, it's near impossible to be creative and do interesting stuff. And all of software is a creative process. It really is as much of an art as it is a science, if not more of an art. Because it's creative problem solving. How do we take a problem, break it down into small enough, simple enough steps that a stupid computer can solve it for us? It's really what it is. And there's so many different ways you can take big problems and break them down into small pieces. The act of telling a computer what to do, that's the technical piece. We're learning that as we go, but really what you're learning to do in college here is how do you solve problems? What tools and techniques, what are we going to add to your toolkit that you can use to take big problems that are hard and complex and make them simple enough to solve them? Right? That's why software engineering is a tough skill. Not everyone can think that way. I used to think everyone could learn it. I'm a little bit optimistic when it comes to certain things, I suppose. I'm a little bit optimistic that anyone can learn. I had asked some folks, so the game lab is fantastic for Dr. Bruce's classes. He's got an amazing game lab. I used to hang out in there. I'll probably be in there a lot as well for my C# class. They do game stuff, and they have to use the game lab. So I might change my office location. We'll see. I'll let you know. But hanging out in the game lab, I talked to some juniors and seniors. They're like, hey, what advice would you give to freshmen who's struggling with CIS 150 or 200? They're like, change majors. If this is not going well, you're in for 4 years of more of this. Like if it's not clicking, maybe try it again, maybe. But if not, change majors. It's not for you. And I was like, that feels mean. Like, no, because they're going to spend so much money before they fail out their junior and senior year doing even harder stuff. That if you don't know how to solve problems and take something complex and break it down into step by step by step by step stuff, if you can't be creative like that, it's not for you. So that was their advice. So again, I'd like to imagine most people can do it. I think most people can, but I have found it's very hard for some people, and that's okay. So we'll see how it goes. Have some fun with it. But yeah, the student food pantry, that's where we went. I go off on rabbit trails a lot. I'm sorry, but if you don't have those sorts of things, you can't do the creative stuff and learn it. I get it. So we have the student food pantry available, which is great. COVID policy. This is still copy paste from the template. Things are going around. I record everything, so please don't come when you're sick. I have 7 kids. I have enough germs at home. Right? I don't need more of them. You don't need to get sick from someone else. Great. Just don't come and watch the recording. Everyone will be happier, I promise. Okay? Please don't come when you're sick. University-wide policies, all these other sorts of things you should be able to find in Canvas, which is great. I don't have to copy paste them in here. It keeps the syllabus a little bit shorter. All right, so that was me reading to you. I apologize. Hopefully hitting the important stuff. We okay so far? Questions? And if you've got questions, please just shout at me. If you raise your hand, I might not notice right away because sometimes I just am absent-minded and focused on whatever I'm doing. Just holler at me. It's okay. Because if it's not clear to you, I can promise you it's not clear to someone else in the class. And you're doing them a favor by being the brave one to ask the question. Okay? So anytime, interrupt me anytime. It's okay. This time is for you. Anyone can go buy a book and read the material. Right? Ideally, what you're paying for is someone to help you with it and answer your questions. So when you have a question, you have someone you can go and ask, hey, what doesn't make sense about this? So let me know. Like I said, I've been doing this for almost 20 years now. This summer will be 20 years since I started working. It'll be fun. So some things that I might go over really quickly because they make a lot of sense to me don't make a lot of sense to you. Right? That happens when you explain things. If you know a lot about something, you go to explain it. You explain it at a different level of detail sometimes than someone who doesn't know it. So just holler anytime. Not formal at all. You can call me Eric. I'm happy with that. Calling me Mr. Chernesky makes me feel old, even though I am an old person now. It sneaks up on you somehow. So Eric is perfectly fine. Again, I'm not a professor. I'm not allowed to use that title until I've taught for 5 more years and then ask them very nicely and fill out a bunch of paperwork, which I hate doing, until I can use that title officially. So fun stuff there. All right, so I got the syllabus out there. We'll have lab today, 4 o'clock over in the ELB. We'll hang out over there. We'll work on GitHub. So if you had me last semester, it'll be really quick. Refresher. If you haven't had me yet, it'll probably take a little while, and that's okay. There's a bunch of steps. So I'll show you what to do. So the first thing we do is we go out to GitHub. Goodness gracious, if I can type github.com, and you're going to sign up or sign in. Right? If you have an account, great. If you make a new account, great too. You have to give them an email address. I don't care which one you use. It doesn't have to be your college one. If you use your college one, you can get some free stuff from them because they're like, hey, you have an EDU account. Here's a bunch of free things. The idea being you're given free things so that later when you're out of college, you go pay for those things. Right? It's the drug dealer analogy. Your first hit's free. Right? That's what they want you to do. Use all these cool tools. They do cool stuff so that later you'll go pay for it. A lot of cool things. We don't need all the other cool stuff though. So we're just gonna go sign in. I'm not logged in, really? That's weird. Maybe it logged me out after a while. I've got 2-factor authentication turned on. I would recommend you do it because it's good. You don't have to, that's fine. But 2-factor authentication is not hard to do. It just takes an extra step here. Useful though for everything out there because it's really easy to get hacked if you click on the wrong stuff, and then it's really sad. So. Not too bad to do 2-factor. It just takes another minute here. All right, there we go. So github.com, I'm logged in. You get a page with your username on it. Chernesky, I can't spell anything. That's okay. Still too early. So this is my profile. So whatever your username is, mine's Eric Chernesky. It's pretty easy. I'm the only Eric Chernesky in the world. Pretty easy to find if you Google me. It's got all my repositories. I got to go and actually clean this up here. I got to turn some of them off. And then it makes this cute little timeline, which is fun. There's a whole joke about people out in the West Coast in Silicon Valley posting their GitHub timelines places. And okay, it's fine. But you make repositories. A repository is just a folder. That's all it is here. So we're going to make a new repository for the class here. All the code that I do in class will go into this public GitHub repository because that's where code should go in a tool that's meant for code. I'm not going to post it in Canvas because Canvas sucks for dealing with code. Right? It does. It's awful. Okay? So we're going to make CIS 200. This will be winter 2024. Goodness. This is public here. When you make repositories, you're welcome to make them public for stuff that you do. When you do classwork, I've got a little link that I use. GitHub has a classroom tool, which is fantastic, which will make private repositories. If it's private, you have access, and because I gave you the link, I have access, which is good. No one will go find it and copy off of you, right? Because if someone turns in the same thing as you, I think you both cheated. Does that make sense? Right? If someone turns in your work, I'm like, hey, where'd they get it from? You must have given it to them. You can't give people work either. That's also cheating, right? In case you missed that bit here. So if someone says, hey, I just want to see how you did it, tell them to get lost. Right? Don't share your code with people. It's bad for everyone. Okay? You are welcome to talk about it. I've got a Discord server. If anyone wants to join, I'll post the link for you later. Talking about things in English, perfectly fine. Give each other ideas. Right? The moment we start writing code down, though, we've gone too far. Right? But if you want to talk in English and just say, hey, here's my thought, these are the things I want to do to solve the problem, that's great. Work together on it. Come up with a plan, but then you're going to write your own code. And when you write your own code, it comes out pretty unique. Each person kind of writes their own code, has their own style of code. It's pretty easy to tell that it's yours. And it's pretty easy to notice when you do someone else's style. Okay? So, great. Talk about it in English. Perfectly fine for the projects. All right, I need a README. And then when we use Git, Git is a source control tool. The things you're supposed to put in Git are source code. Things that you generate or build from the source code, like your executable files, object files, all sorts of link files, those sorts of fun things, you don't want to put in Git because you don't need them. You can go and build them from the source code. So this git ignore is a special file that says, hey, don't put things into Git that I don't need. Ignore these things, please, which is great. So it turns out they have templates already. So the C++ template we'll take a look at will ignore all sorts of C++ related build junk that we don't need, right? Because we don't need to put that in. All we need to do is put the code in there. And then I'm going to put a license on here. I think the MIT one is pretty easy because I don't care. People can go and use it if they want. It's nothing special here. We're mostly just paraphrasing textbook stuff that we've done for years and years and years and years and years, right? So I don't care if anyone uses it. It's not interesting, okay? When you make repositories, if it's public, probably attach a license. Again, you're probably not going to do anything super interesting, but eventually if you ever want to commercialize your stuff, you either don't make it public or you make it public with licenses, and you can do all the other sorts of fun stuff later. I think this whole entrepreneurship class, is that the right word? Goodness, that's a big word. You can take, it's like Engineering 400 or something. Everyone loves to take that because it's a blow-off class for one of their intersections. I forget which one it is here. You have to do something in the DDC. It's like letters for everything. Dearborn Discovery Corps. Wow, there's way too many letters out there. Okay, so this is a repository. This is just a folder. That's all it is. Git tracks this stuff. GitHub gives you a way to view it online and acts as the central repository. Right? The idea is it's very useful for teams. It's great for individuals as well, but for teams to collaborate, it's great because this acts as the central place. Everyone puts their changes in the central repository, and then we can go and get their changes. I don't need to email copies around or have shared drives or do all sorts of crazy nonsense to get stuff out there. We'll use GitHub as the central location. Everyone will sync with GitHub. So this puts it out in the cloud. GitHub is owned by Microsoft, so if you also have your stuff in OneDrive, now Microsoft will have 2 copies of it, which I always think is amusing. Sure, if you like it there, go for it. You don't need it in OneDrive because you'll have it in GitHub. But whatever you want to do, that's fine. So the individual files you can actually click on and look at, which is fun. So the gitignore file here, it gives us the text view of what's here. So it's saying, hey, anything that's an OBJ file, star.obj, star.slo, any of these O files, compiled object files, don't put into Git. We don't need them. I want the source code, the CPP files, the H files, HPP files. Those are the ones we want, right? Other things, we don't add DLLs. Don't Fortran modules? Goodness, gross. Static libraries, executables. Don't add the EXEs, don't add the outs, don't add the apps. Right? Anything that we build, we don't want to add to source control because it'll change every time anyway. Right? That's all this gitignore does for us. So this is a folder. It's fancy. What we want to do now is get a copy of this folder on our computer. Right now it's only on the website. Here. So these are the steps we're going to go through once I give you the classroom link. I'll show you that for the lab in a little bit here. So there's like 5 ways to do this. Right? I like this way, but any way you like is perfectly fine. So I'm going to click the green code button and say open with GitHub Desktop. If you haven't installed it yet, it'll say, hey, you should go install it. It's a pretty quick download. It's easy. I already have it installed, so I say yep, open it. It will launch the GitHub Desktop tool and say, hey, I want to take this website. This is my repository website, and I want to put it here on my computer. Generally, I like defaults, but this one wants to put it in my OneDrive where I don't want it because OneDrive it gets annoyed when I delete things or like, hey, you changed something in your file and a bunch of files change and it prompts me and I get irritated at it very easily. Little things irritate me. I apologize. So I'm just going to change that here and say don't put it in OneDrive. Just put it in C users, Eric C, documents, GitHub, CIS 200 2024, winter 2024. This is where it will be on my computer. Anywhere you want to put is perfectly fine. If you want to have a folder for school and have a folder for winter and have a folder for this class, go for it. It doesn't matter where it is as long as you know where it goes. Right? I like that it's in my Documents GitHub folder because that's all where all my GitHub stuff is. That's the way I do it. Right? Anywhere you want to put it's fine. And I'll say clone. Clone is the fancy term for make a copy. Right? We're going to clone this repository. So now the central github.com repository has a copy of it, and my computer, my laptop, has a copy of it. Git is a distributed source control tool. So anybody who has a clone or a copy of the repository has everything, which is really cool because that means the entire history of things. So if you go out to like github.com, take a look at Microsoft here, they've got their VS Code tool, which is a great tool, great editor. They've done a nice job scaling this idea from other people. Sublime Text and Atom and other companies who were selling these sorts of tools now are struggling because VS Code is free. But again, that's kind of what Microsoft does, which is good and bad. I don't know. Sure. But this is their GitHub. So there's a history of 117,472 commits, times that this project has been changed. A commit is a change to the project. That's what it is. So you can click on this and you can look at the entire history of anything that's happened ever to the files that have been changed. And you can go as far back in the history as you want to go, as bored as you are. So fix a memory leak in a tree. So these commit messages will show up here online. Depending on where you work, they'll have different standards for what things you should put in your commit summaries. We'll talk about that. I don't care what you put. Some people swear at the computer. I find it a little bit amusing. I don't want you to be frustrated at your computer and frustrated at the code and at the work. but occasionally it's okay to get it out. Right? It's not going to offend me. But you can click on that and it will say, hey, these are the files that changed here. So I can see, hey, this tree viewer service.ts, this is a TypeScript file, changed here, and this is what changed. So red things went away, green things got added. So Git will track things at the line level and say this line changed, this line changed, this line changed, all through the file. And you can see, hey, line 9, 10, and 11 changed. Line 25 changed. Line 29 changed, right? We can see these different things change at the line level. We can track all of this stuff here to see what changed when, which is super cool. So somehow this fixed a memory leak. Sure, I don't even, oh, maybe clearing it out? That might be why. I don't know exactly what it is here. But you can go and see it. So this is one of the cool things Git does for you, is it lets you view them and view the history here, because when you have a copy of the repository, you have the entire history, right? It's distributed. So anyone can go and look at any one of these 117,000 commits and see what it looked like at that point in time. You can kind of rewind history of the project here and see it, which is really fun. Or if you just want to go and look at one of the files here, anything that's a folder, you can click on and it will open, and it will show you the contents of that folder, right? So we go and look at, I don't know, not Node, Node's a boring one. Maybe in this one, Electron, app.ts. This is all TypeScript, and hey, look, they've got copyright licenses, but it's the MIT, sure, these sorts of fun things here. So you can see what the code is actually doing, and you can view it right online here. If I want, I can grab the line number and click on it, and now I have a link here. I can copy paste or send over Discord or email, say, hey, I'm having problems with line 175 here. I'm getting an error eventually, or can you help me figure out what's going on, Eric? You don't have to email me code files. You don't have to send me screenshots. Right? You can just send me the link here. I can go view it online. I've been doing it long enough. Most of the time I can just look at your code and I know what's wrong. Sometimes I have to go download and run it in a debugger to figure out what's happening. Most of the time I can just look at it though. And because it's online, it makes it so much easier to do that. This is why GitHub is amazing, because it's a tool meant to host code, not Canvas, not email. Please don't email me code. Nothing irritates me more than having people email me code, because then I have to go do something with it. Right? I have to copy paste it. It takes more of my time. Right? I'm a very lazy person. But good software engineers, good developers are lazy. And I mean that in that they're efficiently lazy. They don't want to have to waste time on things they don't need to. Right? If we use our tools, we save time. Saving time is great, because the more efficient you are, the more work you can get done in a shorter amount of time, the faster you get done with your week. Right? Software engineering typically is not an hourly job, it's a salaried job, which means you get X amount of work to do, you get it done when you get it done. Again, different companies have different rules, and some people are like, you have to have your butt in the desk 40 hours a week. Those places are stupid. Don't go work there. Or if you want to, go for it. That's perfectly fine. But more we're realizing, hey, we can get work done on our own schedules, on our own time. When we get the work done, we get the work done. Great. If you get all your work done early, and you're like, hey, boss, I want more work, they'll probably go give you more work, which is good. It'll make you look good. Your reviews should be good like that. And at a good company, it helps you move up faster. That's great. In a toxic company like Uber, then you just get more work and the managers sabotage you so you don't get promoted and get their job. Uber's an awful place. Please don't go work there. Please, it's terrible. There's a whole New York Times article about how awful it is. People sabotaging other managers so that they would look better and get better. Like, it's just terrible. Right? Look up companies before you go work there. See what their culture is like. Because you're going to be spending more time with the people you work with than you do anyone else in your life, which is a sad but true thing. Right? Generally, we spend 40 plus hours a week at our workplaces. We get to work with those people all the time. So you want to work somewhere that has a good culture, right? Treats their people nicely, is not toxic. So not Uber. Okay. Maybe they've gotten a little bit better. They fired the jerk CEO, which helped a little bit, but that's okay. Anyway, wow, how do we get here? What were we talking about? GitHub. I've got a copy of the folder. Something like that. All right, so now that I have this project here, I have this folder on my computer. If I don't remember where it is, I've got a little button here that says Show and Explorer. Show and Explorer is one of my favorite buttons. It opens it up, and I can click on my little path here and says, hey, see users, Eric C. Documents, GitHub, CIS 200, Winter 2024. This is the folder. I'm just going to copy that path here. Control-C for copy. That's your favorite shortcut ever, I promise. Control-C, Control-V for paste. That is the most useful shortcut you have. There's a little joke here. What is it, the Stack Overflow keyboard? Keyboard. I can't type keyboard. Come on. It's cold. Here you go. This was a March 31st, hey, April 1st, New Year's, or April Fool's Day thing. Copy paste. Control-C, Control-V. This is the Stack Overflow. I think someone actually sells this, I want to say. So you can whatever. But copy paste, the most useful thing you have. Okay. Now I'm going to go to Visual Studio. I'm going to say, hey, I want a new project, and I'm going to put it in that folder. So because all development environments know what Git is nowadays, they've got options here. You can clone repositories. You can do stuff right in Visual Studio. Again, I don't recommend it. You're welcome to do it if you like, right? But that's not what I'm going to demo. So I'm just going to say I want to make a new project. And what do I want to make? Well, I want to make an empty, I'll just do a console app, right? This starts me with some more things here. A little bit of extra fluff, but that's okay. I'll clean it up after. I want a console app. Where do I want to put it? Right? Now, this is where I have to go paste in that path or go browse. This is an ellipsis, the 3 dots. It's a fun technical term there, ellipsis. It's a fun word to say, ellipsis. Ellipsis. You can go browse to it if you want. Perfectly fine, but the browsing is a little bit annoying. Those shows. I'll put it in here. I'll say, what do I want to call this? We'll call this Hello World, because everyone has to do Hello World every time. I didn't make the rule, I just follow it here. So every time you start a new language, you make a Hello World program. That's the fun thing to do, okay? Now, this little checkbox here, place solution and project in the same directory, I don't care. Some people like it, some people don't. I've not gotten used to doing it this way, and eventually we'll get into, the idea with a solution is it's one or more projects. Eventually we'll start using multiple projects when we start talking about testing, because test code doesn't belong in your production code. You want to separate those things. So having separate projects allows you to physically separate them, and then when we build and deploy something, all the test stuff gets ignored, which is fantastic. And we'll talk about that when we get there. So I don't generally check that box. It doesn't really matter, just cuts out one folder. And I'll say create. So if I put it in the right spot, the GitHub desktop client says, hey, there's a bunch of new stuff here now. Look at all this cool new stuff here. Eventually, the one we really care about is the CPP file. All these other things are nice, but we don't really care too much, right? The VCX proj, Visual CX project. I don't remember what the X is for here, but this tells Visual Studio it's a project that you can open. And then there should be a solution in here too. That's interesting. Did I not get one? I don't know. There's some other stuff in here. That's fine. Basically, anything that's these other VS files, we can just ignore. That's okay if they're there. If they show up, they show up. Just let them change. We don't care. What we do care about is our code file, right? And now I can go, I'm going to clean out all this cruft here because that's perfectly fine. I'm just going to make sure it runs. Right? You always want to make sure it runs. Hey, hello world. All right, we got hello world. And again, this little prompt here, you can make it automatically close. I don't recommend that because that's obnoxious. I think it's nice to have it not automatically close, but up to you. That was fine. Now I'll come back to GitHub. Hey, okay, now here's all the other stuff. Why is this not? I shouldn't have all this other junk. I think I did it wrong. I did it wrong. Hang on. Yep, that's what I did. Okay, I have the wrong ignore file. GitHub Studio ignore. That's what it was not C++. That was the wrong one. I want the Visual Studio ignore file because we're in Windows land. Here it is. Okay, so I just need to go update my ignore file. This is what I want here, because this will ignore more stuff here. All right, I'll make sure you have the right one. When you get projects, this gets created for you, which is really nice. So you don't have to go and change this yourself, but you can go change it anytime you want. So I'll say, hey, show in Explorer, go find my git ignore file. I'm going to go edit this file, open with code. Fantastic. It's a great editor. Copy and paste, give that a save. Now most of that stuff goes away. Okay, now I'm happier because it's ignoring all the stuff it should ignore. All the extra Visual Studio things that we're supposed to ignore here. Any of this VS Code stuff, the VS stuff, it's in here somewhere. There's lots more stuff in here. I should have picked the right one. Yeah, this debug, anything release, any of those stuff gets ignored. Any of the user files. Okay, all that stuff gets ignored. Now we're happy. It doesn't hurt to put it there, but you don't need it. It's just extra cruft, and it will change a lot here, and it just gets irritating. So now we see our solution file, a CPP file, project file, and a filters file. That's what I was expecting. Okay, and with the commit here, a commit is just a snapshot, the point in time. So the commit says, take a picture, save the state of the folder. Here's what changed, and we'll track it again by line level here. So I'm going to do just the ignore file first here because that makes me happy. So update git ignore, and I'll commit that. Now my computer has a commit. The central repository in github.com does not. So now my button here has changed to push. Git uses the idea of pushing and pulling. So you push changes to the central repository, you pull changes from the central repository down. That's how we keep in sync. It's a manual sync process. OneDrive is an automatic sync. GitHub is not, because you probably don't want your code to be updating real time. Right? We're going to make snapshots and sync manually here. So I'll go and push that one change. And now I'm back in sync. Now I can go back to fetch. Fetch just says go look for changes, essentially. And now I want all of these files changed here. We'll just say here's hello world. Again, this is the commit message, the summary, the small box here. This one is required. You have to have something there. I don't care what you put there. Other organizations have certain rules, and that's what shows up like when we were looking at the VS Code list of commits, right? Your commit summaries showed up here. So you can see this is when this particular file has changed. When has apt.ts changed? Well, allowed cores, it added, like, here's some useful things, hopefully. And if you've worked in the project, it probably means something. And again, it doesn't mean a whole lot of things, right? Aux window enables some menu actions when aux window has focus. That's useful, right? You can see what the intent was, what were they trying to change here, which is nice. So those commit messages show up. So then I say commit. Now I have the option to push. Again, there's like 3 different places to push. You can go to repository push, you can click push up here, you can click the blue push button. The blue tries to highlight, here's the active thing you're supposed to do. So anything you see in blue is probably a good thing to look at. Right, so we'll say push. Now that change is pushed out to the main website. So again, if I don't have the link open, I can go back to the GitHub desktop client. I can say view on GitHub. It'll launch out the website for me. And I'll see now there's a folder for Hello World. And the git ignore has been updated, right? My updated git ignore a minute ago, 15. So you can actually see when these things changed. So when you turn in your work to GitHub, it's all timestamped, right? Then you turn in the link to Canvas, and it's great. You just give me the URL here. Say, here's my repository. This is what you're going to turn into Canvas. Okay. Again, we'll show you how to do that. We'll work through it in lab. We got 15 minutes left this morning, and then we'll work on lab this evening. Afternoon, 4 p.m. still afternoon, right? It's not evening. I don't actually know when evening starts. 5:30? Okay. Yeah, so afternoon, we'll work on that. So the Hello World folder, I can click on it. The solution file, again, not very interesting. Hello World folder, again, because this is the project folder. I can click on it. I can find the CPP file. Here it is. I can see my code. If you can see your code on github.com, I can see your code on github.com. If you don't see your code on github.com, I don't see your code on github.com. I think that follows, right? So if you're not sure if I can see your code, go see if you can see it. Okay, if you can see it, and then so all of your repositories are going to be linked in my my organization. It's called Chernesky. Eric Chernesky seemed to, I was already as my username, so it would get confused. So it'll be a Chernesky in the URL. If you don't have a Chernesky in your URL, you might have made it as your private repository. That's the only downside. If it's a private repository that only you can see, I can't see it. Okay, there's ways to give me access, but I would prefer you just use the ones I give you. Right, that makes life easier for all of us. Okay, it's extra steps for you to go give me access. Okay, so if you see Chernesky in the URL, you're probably in good shape. Okay, and I'll talk you through it here in a minute. Okay, so then let me go to my classroom link. I go log in, make a new classroom in Chernesky. All right, so this is CIS 200 Winter 2024. All right, we don't need any of that. Continue. I should have hit skip. That was silly. All right, and then we're going to make a new assignment. So this is CIS 200. This is Winter 2024. This will be Lab 0. Remember, we always start counting at 0 like normal people do. 0, 1, 2, 3. Like programmers count starting at 0 because we're smart, right? Because of arrays. It's funny. No, okay, sorry. Not enough coffee yet. So Lab 0, right? It'll be a private repository. Okay, and then I'm going to I have a template here to make sure I give you the right ignore file. This is my C++ template. Here we go. So the C++ template, we'll use that one. Create and create. There's a bunch of other interesting stuff we can do. I don't use most of the bells and whistles because we don't need them. All right, so here's the link. So in Canvas, now there is a lab section and there's a class section. I'm going to just ignore the lab section because all of you are in both. Pretty 100% sure about that. Usually you have to register for the same lab section as the lecture section. Okay, I thought that was good. So I'm not going to use the lab section because then I have to do a bunch of work to get lab scores over in the main class that you get points for. And I don't want to do more work. Is that fair? Okay, right, I'm efficiently lazy, right? So we'll make a labs group here, and then in labs we'll add a new assignment here. This is lab 0. This will be due, that's not a date picker. There we go. Next week, so they're due the next week, 11:59 p.m. for labs. So you've got all week to work on it. If you didn't get it done, you can bring it to next week lab. I don't recommend that. A couple people got into that habit. They were always a week behind on labs, and then you're behind on the practice that you need to do for the projects. So let's try not to get behind. If you do, it's okay. You can get caught back up. We'll get there. It's not the end of the world. And all the labs are worth 10 points each. But again, that only matters in the lab category. It just makes math easy here. So I give you the link here. We're going to please submit the URL to your GitHub repository. Include screenshots of program running in the README file. I'll show you how to do that in a second. All right, so we're going to write a hello world style program that introduces yourself. Please output your name, major, name and pronouns, major, reason for taking the class, and if it's required, perfectly fine reason. That's really okay. That's fine. And a fun fact. And a fun fact about you. Okay, great. And then you're going to turn in a website URL. You're going to give me the URL to your repository here. Okay, so I'll save and publish. So this will be in Canvas. I'll do it for you here for me, and you'll follow these steps. And it's recorded. You can go watch it again later if you want here. So the first thing we're going to do is click the link for the GitHub Classroom link. It'll say, hey, do you want to accept the assignment? Sure, let's do this. Well, let's accept. If you haven't done it before, it'll say, hey, GitHub Classrooms wants permission to your GitHub account. Just say yes. Okay, that's fine. It says it might take a few minutes. It takes like 5 seconds, if that. So just go refresh your page. Now you have a URL. This is the private repository that you have access to and I have access to. Okay, you see Chernesky's in the URL. You did it right. If you don't see Chernesky here, I don't know what you clicked on, but you didn't click the right thing. Okay, so it'll be CIS 200 Winter 2024 assignment name dash your username. So if your username is I love Mac, then it'll be lab0 dash I love Mac. Right? Eric's a Windows fanboy. That's just sort of what I am. That's okay. All right, so this is what we're going to turn in eventually. It's an empty folder. It has the git ignore and the readme. So we're going to use this readme in a little bit. All right. So to get this folder on our computer, and you can do this on the lab computers, you just need to install GitHub Desktop. Again, we go to the code button, say open with GitHub Desktop. It says, okay, do you want to make a copy of it? Yes. It remembered I don't want to put it in OneDrive. Great. This because I did it last time. So it's going to make this URL, a copy of this repository, this location on my computer. Great. I'll say clone. Again, it doesn't really matter where it puts it. So I can say show in Explorer, and I'm going to grab this path and copy it. I need this path, or I have to go browse for it in Visual Studio, right? So go to Visual Studio, go to a new project. I want a console app because that's easy. We'll call this one Lab 0. Again, the names don't really matter. I don't care what you call it, but this will organize it nicely for you. I'm going to put it in the Lab 0 folder here. Again, CIS 200, Winter 2024, Lab 0 dash your username here, right? Whatever your GitHub username is, it'll show up here, right? We'll create. Now, I don't need all this other junk here. We'll take out all the comments. I don't need any of that. And we just have to go add some more couts. And again, I like the using namespace, standard namespace, using namespace standard. There we go. So you don't have to do the standard couts. Someone told me once that that's bad. I don't care. It's easy for what we're doing. When you get into large enterprise projects, apparently this can cause issues. And you know, the organization that signs your paycheck, just smile and nod. Like, okay, you don't want me to use it? Fine, I won't use it. It's pretty easy, right? The organization, the person that grades you, you should probably do what they say, right? Okay. As for comments here, I have a little bit of a bad tendency to ignore comments and not use them because the general industry feeling about comments is they're worthless because your code can change and the comment would stay the same. And now you have a stale comment that doesn't make any sense. And if your code doesn't make sense without a comment, you could probably do better with your code. Probably. Now there are some times when comments are very great and very useful, especially when you're writing libraries. Some of the like descriptive stuff about documenting your code, fantastic, and I love it. We're not doing any of that nonsense, so I will never ask you for a comment. Back when I took my first programming class it was even a high school student, I was dual enrolled because yeah, it was fun stuff. My school let me do that. I got marked down on a project, and I was pissed off because I didn't know why I got marked down because it did all the things it was supposed to do. Turned out the prof wanted to comment on one of the functions, and I didn't comment it. I'm like, but the code works. The code does what it's supposed to do. So I swore back in 2004 that if I ever had a chance to teach, I would not give points for comments or take points off for not having comments, and I've stuck to it to this day. I don't require comments. That being said, when you get to other classes and the prof says or the lecturer says, I want comments, you smile and nod, okay? I could care less. Some people do really nice things. They're like, hey, this is Lab 0, author Eric Chernesky, this sort of stuff, last modified. You know what's fun about this? All of that's in Git. I have your entire modification history. I know who did it because you used your GitHub username. I know what it is because you named it, the project. Like, this stuff is stupid to put in there. You can tell other people I said their comments are stupid. Go for it. Tell the other profs I think they're stupid. It'll be fun. Anyway. All right, so we need to output our name. So I am Eric Chernesky, he, him, And then I like this, what is it, environment.newline. Goodness, what is it? Endles, there. I like those instead of the \ns. This is supposed to be slightly better if you are cross-platform. Macs and Windows do different things for endlines. Sure, so the endle is supposed to be a little bit better, whatever. So my major, I'm not currently in school. I was enrolled in the doctoral program and had to drop out due to some family issues. Daughter had a medical issue we're working through. It was a lot of fun. Research, and actual research, I mean not watching YouTube videos that agree with you, is very time intensive. Super interesting stuff. So would love to get back into it at some point here, but not a doctor. Don't call me Dr. Chinesky. Not there yet. We'll get there. So I am the teacher. I have to be here. You're in the classes. It's a required class probably for most people. Occasionally we get other majors who aren't software engineers. I apologize that I ignore you. I love non-software engineering people taking coding classes. That's great. A kid I went to high school with is a paleontologist, got his PhD, teaches at New York something or other, Institute of Science, or whatever. He does more R coding than I do as a PhD paleontologist because he has to write code to analyze. His PhD thesis was on the morphology of bird skulls and had to take 3D images and analyze the changes in skulls in birds over all the years. And this kid can code in R, like in circles around me. It's a little bit embarrassing. That's okay. Like that's what he does. Like that's his specialty, is analyzing 3D images in R. It's like, okay, yeah, fun. Anyway, and then fun fact about me: I am a runner. I'm training for I think this is my 10th marathon. So every year, except this last year because I got sick, I've done the Detroit Free Press International Marathon because my buddy talked me into it. I used to run in high school, or middle school and high school, and I got out of it in college because life got busy. My buddy's like, hey, you should come do a marathon with me. It's like, okay, that sounds like fun. So I signed up, and then he didn't sign up in time, and it ran out of spots, so I had to run it myself, which is okay because he's a lot faster than I am. Would have been embarrassing. So this is the first one back in 2014 I ran, and I've done it almost every year since. It's so much fun. Great chance to run around here. That being said, I do like to run, and briefly we skipped over the safety things. You're all adults, and I have no responsibility for you. So if there is some sort of safety event, I am out the door on my way home to my 7 kids. So I will not wait for you, and I will run, and I will run fast. Okay, just to get that out there ahead of time. If we have to, we can lock down things, but generally it's probably not our building, and we will just run like hell. Okay. Should never get to that, but sorry we have to talk about that nowadays because the world sucks. And this is what we live in, so we'll make do. All right, for the lab, let's see. I'm going to go back to, I've got it here. Here it is. Name, pronoun, major, reason for taking the class, fun fact about you. Great, I got it all. So here is lab 0 complete, or done, or something like that, sure. So if I see stuff in GitHub, I know I put it in the right folder. If I don't see stuff here in the GitHub client, I didn't put it in the right folder. You can go copy paste it over. Cut is actually probably better because you don't want to have 2 copies of it on your computer because then you'll be confused about which one you're editing. But you create the project in the folder and it will find it for you. If you make the project first and then go get the GitHub repository, you have to do more work. Right? You don't want to do more work, right? You want to be lazy. Be efficiently lazy, okay? So lab 0 done, I'll say commit and I can push. Now I'll go show and explorer. I'm sorry, no, view on GitHub, right? I want to go check it out. Can I see my code online? If I can see my code online, Eric can see your code online. That's a pretty good rule of thumb here. Oh, it's not the right version here. This is why it's good to check. It had the old version here. I never actually saved here in Visual Studio. Notice it's all kind of yellow. It gave me like, hey, this is unsaved stuff. So when you run, it automatically saves. So running is probably good too because we want to make sure it runs here. So now we see back in the GitHub client, it says, hey, lab 0's changed. Here's a bunch of red, here's a bunch of green. Red stuff was removed, green stuff was added, right? So here's lab 0 actually done. This is fine. I probably did that on purpose, right? We'll just pretend it. Pretend like I did that on purpose and push, okay? Now if I go back onto the website and refresh here, it shows the new version. Life is good. This is what I expect to see. Now the last thing we have to do is we're going to show this running. So for labs, it's just a quick picture or two. It won't be too bad. For projects, we're going to take a picture, a screenshot of every step, right? Every item on the rubric. So you get 2 points for doing this. You get 2 points for doing this. You get 5 points for doing this. You'll take screenshots. On Windows, it's the Windows key, Shift, and S gives you the screen scrape tool. So you can like just grab a particular portion here. That's easiest. You can also hit the print screen button, and it will give you everything. That's fine too, if you like. So I'm going to come back to my program running, Windows Shift S, and I'm going to grab the little terminal box here. And this is what I'm going to copy paste. Now, to get it into the README file, I'm going to come back to my repository. This is the step I'll take a little bit here. I don't recommend doing this on your computer. You can, but images are funny here. So if you just hit the little pencil here to edit the README file, you can come right in here, just come down a line or two, right, not on this first line here, and just hit paste, and it will add the image for you automatically. It uploads it, attaches it, gives you a link. It's fantastic. You just say commit, I don't know, screenshot or something. That's the commit message here. We'll commit. And now the README file has the image. If it doesn't show up right away, just hit refresh. Sometimes it takes it like 5 seconds for it to actually get the image. But now there's an image out there, and it's in the README file. So if I look at the repository, I see the screenshot here. Okay, now I've got the screenshot. That's the last step. This makes it easy for me to look at and make sure that you actually ran it and it did what it's supposed to do. When you use the rubric for your projects, you'll be broken down step by step by step. Here's what it is. So that's what we're going to do for lab this afternoon. I'll see you at 4 p.m. over in the ELB. If you got any questions, let me know. I'm looking forward to a great semester. Ask me questions, please. I love hearing from you folks. I get really bored of hearing my own voice. And if you've got questions, other people have questions. And ask anyone else who had my class before. I'm kind of nice. Kind of. Most of the time. Okay? Thanks. I'll talk to you later.